Flash welding is a type of resistance welding that does not use any filler metals. The pieces of metal to be welded are set apart at a predetermined distance based on material thickness, material composition, and desired properties of the finished weld. Current is applied to the metal, and the gap between the two pieces creates resistance and produces the arc required to melt the metal. Once the pieces of metal reach the proper temperature, they are pressed together, effectively forging them together. Parameters. According to a study published in Materials and Design, several parameters affect the final product. Flash time is the time that the arc is present. Upset time is the amount of time that the two pieces are pressed together. Flash time needs to be long enough to sufficiently heat the metal before it is pressed together. However, if it is too long, too much of the base metal begins to melt away. The upset time is critical in creating the desired mechanical properties of the finished weld. During the upset, any impurities in the base metal are pressed out, creating a perfect weld. If the upset time is too short, all of the impurities may not be pushed out of the base metal, creating a defective weld. The upset time is also crucial in the strength of the finished weld because it is during the upset that coalescence occurs between the two pieces of metal. If the upset time is too short, the two pieces of metal may not completely bond. Very often flash butt welding is controlled by distance rather than time, such that the flashing would occur for a predetermined length, say 5 mm, before the upsetting cycle starts. Upsetting may then also be controlled by distance. A parameter would be set to apply the upsetting force until a certain distance has been upset. It is generally the upsetting distance that is more important than the upsetting time. At the end of upsetting there is commonly a hold time, during which the joint is held still to allow the joint to cool and the two pieces of metal to completely bond. Applications. According to the Journal of Materials Processing, the railroad industry is using flash welding to join sections of mainline rail together. This mainline rail is also known as continuously welded rail and is much smoother than mechanically joined rail because there are no gaps between the sections of rail. This smoother rail reduces the wear on the rails themselves, effectively reducing the frequency of inspections and maintenance. In other countries, continuously welded rail is used on high-speed rail lines because of its smoothness. A study published in Materials Science and Design proved that flash welding is also beneficial in the railroad industry because it allows dissimilar metals and non-ferrous metals to be joined. This allows crossings, which are generally composed of high manganese steel, to be effectively welded to the carbon steel rail with the use of a stainless steel insert, while keeping the desired mechanical properties of both the rail and the crossing intact. The ability of this single process to weld many different metals with simple parameter adjustments makes it very versatile. Materials and Design discusses the use of flash welding in the metal building industry to increase the length of the angle iron used to fabricate joists. The aluminum industry uses flash welding to join aluminum, steel, and copper in various current-carrying conductors called busbar. The steel is used for strength, the copper is used for conductivity, and the aluminum is used for a combination of cost and conductivity.